To properly address the challenges of modern financial technology systems, one should have a scalable and resilient way to model, generate, execute, and interpret arbitrarily many diverse tests and their permutations against any number of environment configurations, as well as to simulate, observe, and collect traffic and events from various endpoints and store them for human and machine analysis. In order to achieve all this, we've created a microservices architecture where the system consists of many independent modules responsible for different tasks. They are connected to each other to perform various test activities. Here's the configuration of the test harness. The purpose of some of the modules is to connect to the interfaces of the system under test. Here you can see several client and server fixed connections and log extractors. TH2 supports dozens of APIs and protocols and is integrated with UI test automation frameworks such as Selenium and WinApp Driver. The setup also contains the components for encoding and decoding messages. These include the components to be used in the script for sending orders and receiving responses, the components for monitoring the incoming messages, checking their content and consistency, and finally a programmable emulator of the trading venue and the test scenarios. All these components and their connections are configured here and can be reconfigured and updated anytime without significant disruption of test execution. Now let's see what the active tests may look like. These tests can be written in modern mainstream programming languages and driven by industry standard frameworks such as JUnit, Cucumber, PyTest, and many more. Python, Java, and Kotlin are used in this demo. This is an example of a simple script that generates orders, trades, and order management transactions in the trading venue. Here on the screen, we have an example of a fixed order entry scenario. By using the placeOrderFix method, we are calling ACT to form and send a single order message to codec and then to the corresponding connection. This method also shows the results of this action and displays the corresponding response from the system. Check sequence rule will validate the content and the order of the messages received as a response from the system. It will call the check component, which is working in an asynchronous mode. In case something is wrong, it will indicate inconsistency in the results. Let's execute the test and see the results. All activity in TH2 generates two types of data: events and messages. Events are structured logs of what happened in all TH2 modules, and messages are a collection of all raw data consumed or generated by the system under test. In our case, we will have all the details of fixed messages processed by all connections. In the TH2 UI, we can investigate events messages and link them together. The script generates a root event corresponding to the execution, which will contain all the related actions. As you can see here, the placeOrderFix method calls ACT, sends a new order, and waits for an immediate response. And checkSequenceRow verifies the response content and shows a comparison table with the past actions and messages tab. In case of failure, we will get a corresponding error. Apart from these straightforward tests, we need more complex features. One of the examples is reactive modules, which react to the messages received by TH2. In our demo, we use the simulator component. This component simulates the responses from the system. The behavior is defined by specific rules written as a Kotlin script. For this example, it sends back execution report, reject, or business message reject, depending on the incoming new order single message. It reacts to the message received from the system under test and generates a corresponding answer. Let's see what business message reject looks like in the TH2 GUI when received from the system under test in response to sending a new order single message for instrument 6. On the left-hand screen, you can see the details of the new order single sent for instrument 6. The right-hand screen demonstrates the simulator's response that follows the scenario of receiving an order for an unexpected instrument. In order to verify chaotic system behavior under load, it's highly efficient to cover as many things as possible in passive tests. This means analyzing incoming messages for content and consistency without necessarily knowing what caused these messages. Let's see the reconciliation module of TH2. It's used to check the data independently from the process that causes it. It can validate different message flows using specific rules, for example, those written in Python. The process consists of the following 3 steps. Group, we use rules to split all messages into groups. Hash, we use rules to identify the matching key. And check, we analyze and compare messages joined by the matching key. Here, we have a rule that checks the consistency of execution reports after the trade between participants. All data from the corresponding connections will go through reconciliation, and as a result, this component will provide us with a comparison report. This report will contain matched, unmatched, and failed events that were captured during the executions. We can now see the check performed by Recon that revealed inconsistencies in several fields of 2 execution reports of a trade. Let's make sure a similar mistake is reflected in the script. We see an actual versus expected result check in which the same inconsistency is revealed between the sent and the received data of the same message as in the Recon module. When we run many tests in parallel under load, it's impossible to make conclusions about test results manually. To address this task, TH2 offers data services providing access to structured test data for modern data analysis frameworks. In this example, we're using Jupyter Notebooks to retrieve data about the tests, analyze the data, and collect meaningful statistics about test execution. Here, as an example, we can build stats from different TH2 events or stats based on different message types and their contents, that is, order types, execution types, and other tags from execution reports, or the stats of the events generated during the execution, as well as measurement graphs for the corresponding check and recon events. That's it for our demo. We'd like to thank the fixed trading community for the opportunity to hold this session, and we thank all of you for your attention. We're happy to answer your questions at the virtual Exactpro booth right now, as well as during the rest of the day. Thank you.